evidence of aliens, what to make of research and reporting on Oumuamua, our visitor from space. Now, I don't know if I'm pronouncing this correctly. It's a Hawaiian word, Oumuamua, an interstellar asteroid. This is by Stephen Tingay on theconversationphys.org. As an astrophysicist, probably the most common question you get asked is, where are we alone in the universe, and do aliens exist? There's no doubt. People love to think and talk about aliens, hence stories about the search for extraterrestrial intelligence get picked up and reported with gusto in the media. But what really lies at the heart of this complicated and popular topic is evidence. The nature of an evidence of alien life, any evidence of alien life, and how we view and respect this evidence and how this is communicated to the public. Nowhere is this more important than the coverage of scientific studies of a mysterious object, Oumuamua, that was recently discovered passing through our solar system. For example, 2 publications in 2 respected peer-reviewed journals prompted very different reactions. Hello, Oumuamua. Oumuamua, meaning scout or messenger in Hawaiian, is the name given to the first detected interstellar object to visit our solar system. An interstellar object. On discovery last year, Oumuamua was classified as a comet, but this was later withdrawn when no evidence for cometary activity was detected. Oumuamua was quickly found to have an orbit that does not belong to our solar system. It has an origin elsewhere in our galaxy and a trajectory that saw it traverse the inner solar system over the course of a few months. It passed close to the Sun and the Earth and was found to have an unusual geometry. It was about 200 meters long and some 35 meters wide, rotating every 7 hours. So it rotated every 7 hours. Very strange behavior. The discovery of Oumuamua generated a lot of attention in the scientific community and in the media, given its unusual geometry, its oblong, and its origin outside the solar system. Questions were soon asked as to whether Oumuamua could be a spacecraft. Observations were made with 2 radio telescopes to search for any direct evidence of transmissions indicating intelligent life, including a team led by the person who wrote this article, Stephen Tingay, using an Australian telescope, the Murchison Wide Field Array. We listened around FM radio frequencies, he said, on the basis that any intelligent life on Oumuamua may recognize FM frequencies popular on Earth. No direct evidence of intelligent life was ever found on these searches. More hard data on Oumuamua. Extensive and impressive observations with a range of telescopes, including the Hubble Space Telescope, were made to accurately determine Oumuamua's trajectory. Results of the study by a team of astronomers led by the European Space Station, Marco Micheli, were published in Nature in June. These very carefully observed observations showed that Oumuamua accelerated as it left the solar system, revealing the existence of non-gravitational forces. This means that the trajectory of the object could not be explained just by the gravity of the Sun and other major objects in our solar system. As we said, its speed accelerated when it left the solar system. A range of possible explanations for the acceleration exists. One is that heated gas escaping from Oumuamua, that is outgassing, could produce a force that caused the observed acceleration. This is commonly seen in normal comets. But Oumuamua still shows no evidence for cometary activity. Micheli's team ran through 6 possible explanations and concluded that outgassing is the most likely option, even though there is no direct evidence that this is the case. They showed that the acceleration of Oumuamua is unusual, but within the bounds of what has been seen previously for solar system comets. One of the explanations discounted by the study team is that Oumuamua was accelerated by radiation pressure from our Sun. Radiation from the Sun can push objects away from it. But they concluded that this explanation is not preferred because it means that the density of Oumuamua would have to be very low. Any object needs to have a very large surface area and very low mass, that is, low density, to be accelerated by radiation pressure. It would have to be thinner than a very, very tiny butterfly wing. Now, could it be aliens? Another study by postdoctoral researcher Shmuel Bialy and distinguished astronomer Avi Loeb from Harvard University took a different approach. Details of the study have been published in November's Astrophysical Journal Letters, but were available online earlier. The authors chose to assume solar radiation pressure to be cause of acceleration and then determined the properties of Oumuamua required to make this work. They require an object with thickness less than 1 millimeter and a real mass density of 1 to 2 grams per square centimeter and a large area. It's unlikely that nature would produce such an extreme geometry. The authors quickly mentioned this before moving to a discussion that, under the assumption that solar radiation is the cause for the acceleration, Oumuamua is artificial. That means the product of an alien civilization. The properties the authors derive under their assumptions are similar to those of solar sails being designed and built by humans as a possible way to travel interstellar distances. Bialy and Loeb spend half of their article discussing a section of the idea that Oumuamua could be a defunct or active solar sail belonging to, of course, an alien civilization. The nature and communication of evidence. Bialy and Loeb did not issue a press release about their study, but the media picked up the paper once it was accepted and available online prior to this week's journal publication. And this is something that happened to me he says, in 2012, leading to my publishing Non-Detection of Aliens being run on the front page of the BBC News website. Bialy and Loeb's publication attracted headlines such as this, for example. Harvard astronomers claim Oumuamua is alien probe, nothing like we've ever seen. Most other reporting was more balanced. This is pretty normal. A lot of media jump to aliens in the reporting of space and astronomy, even when the original reported studies never mention aliens. Recent reporting of fast radio bursts, FRBs, is an example. What surprised me was the reaction of some of my colleagues to Bialy and Loeb's paper. On social media, there have been some pretty personal attacks by scientists, on Loeb in particular, for being in the media for his work. Both new studies lay out their assumptions, cite substantial evidence, and undertake rigorous calculations. Both were accepted by top-quality journals after independent peer review. Both finish with bottom lines that the studies of Oumuamua are inconclusive and we will need to examine more such objects that come through our solar system in the future. Both sets of authors also come up with different perspectives and motivate different questions, but Loeb has ended up with the media talking about his paper and is being panned by some colleagues for it. Since the pre-journal paper was picked up, he told me he's been swamped by media interest. Quote, I use the discussion with the media as a platform for highlighting the standard scientific methodology. An anomaly is observed in data, the standard explanation fails to explain it, and so an alternative interpretation is proposed. I encourage anyone with a better explanation to write a paper about it and publish it. Wrong interpretations can be ruled out when more data will be released on Oumuamua or other members of its population in the future. As for the negative reactions he's received, he referred to an article he recently published where he paraphrased another scientist known for his once controversial theories. As Galileo reasoned after looking through his telescope, in the sciences, the authority of 1,000 is not worth as much as the humble reasoning of a single individual. Let's talk about the evidence. Given my work on observations of Oumuamua, a few journalists have contacted me for comment. These have been great opportunities to discuss in depth with journalists the nature of evidence, the difference between something being consistent with observations and direct evidence for a conclusion, and the need for evidence to be commensurate with the impact of a claim. If aliens are claimed, direct and robust evidence is required, not a conclusion based on a few observations that are difficult to explain, plus a bunch of assumptions. But no scientist is claiming Oumuamua is alien in this discussion. They've just raised questions and explored answers. There's no point in shying away from a proper discussion on the search of extraterrestrial intelligence or in being personally critical of colleagues. Scientists should take every opportunity to engage with the public and the media on the topic, given the public's interest and the media's willingness to report. It's interesting, fun, and scientific, and a great opportunity to discuss the scientific method and science in an engaging manner. The media reporting of Oumuamua shows that, aside from a few headlines, the content of reports is generally pretty good and reasonable. Whatever Oumuamua is, almost certainly not made by aliens in my view, it's a fascinating object and presents a lot of interesting scientific questions that will trigger further studies and observations. We will never see Oumuamua again, and we may never know exactly what it is, but seeing Oumuamua in the news is likely to inspire some kids to take up a career in science. This is from Astrophysical Journal Letters from The Conversation, and it's on phys.org. Kindly support my Patreon account, since that's the only way I can continue what you like seeing on this channel. Thank you. You'll find it in the description box below.